Hi there, we've got a structural and bonding exam question that we're going to go through in this video. It's taken from an Q8 Year 2 past paper. It's from Year 1 on the A-level chemistry specification. So the first part of the question requires us to draw a diagram. We need to draw the interaction between two molecules of ethanol. There's one molecule of ethanol and there's another molecule of ethanol. You'll notice that I've put the OHs kind of adjacent to each other on each of the molecules, and that's important because that's the part of the molecule responsible for this strongest interaction between the molecules. The oxygen atom is highly electronegative, leading to a polar O to H bond. This is the same case in both molecules, so we need to put the delta minus and the delta positive on the oxygen and hydrogen on both of those molecules. We need to show lone pairs of electrons, and they're kind of given there by the lobes. So each oxygen atom has got two lone pairs of electrons, and the intermolecular force goes from the slightly positive hydrogen of one molecule, it must be the OH hydrogen, so it goes from a slightly positive hydrogen in one molecule to the centre of a lone pair in a neighbouring molecule. The name for that interaction is a hydrogen bond. Explanation question next, using the data from the question. So we can see from the question that the boiling point of ethanol is greater than the boiling point of methoxymethane, and it gives us the formula for methoxymethane. We can see from that molecular formula that there is no O to H bond present in methoxymethane, so it will not have hydrogen bonds. So the hydrogen bonds between the molecules of ethanol are much stronger than the permanent dipole-dipole attractions between molecules of methoxymethane, so more energy is required to overcome the hydrogen bonds. Shapes of molecules question next, and there's quite a lot in it, so take your time to read all of the information thoroughly. You weren't required to draw dot and cross diagrams, but I have given dot and cross diagrams to show how I arrive at the shapes of molecules. Really, you need to be very fluent with some of the common shapes and be able to get to the shapes and bond angles much more quickly than this explanation, but the explanation helps to consolidate some of the foundations which lead us to our conclusions about the shapes. So in the POCl3, first of all, we know that the P, the phosphorus, is the central atom. It is bonded to one oxygen atom, and it is also bonded to 3 chlorine atoms. Phosphorus is in group 15 or group 5, so as such it has 5 outer shell electrons, which I've shown there as 5 dots. We're also told in the question that the oxygen atom is attached to the phosphorus by a double bond that uses 2 electrons from phosphorus. So the P to O bond has got 2 dots in it, 2 electrons from the phosphorus atom. Chlorine, I have shown the electrons from the outer shell of chlorine as crosses there, and I'm just going to make the assumption that they are single bonds. Chlorine is in group 7, sometimes referred to as group 17, so has 7 outer shell electrons, and we can see there that chlorine has got its full octet of electrons, 8 electrons around each chlorine atom. Oxygen is in group 6, so there's the 2 squares showing the outer electrons for oxygen which are taking part in that P to O double bond, and there are the other 4 electrons making a total of 6 squares, 6 outer electrons for oxygen. It's important to note that phosphorus has got 10 outer shell electrons, but that's fine. Phosphorus can expand its octet and it will make stable molecules in which it has got more than 8 outer shell electrons. So there are 4 bonding regions of electron density around the phosphorus atom. There are 0 lone pairs. The bonding regions will repel equally. So the bond angle, although we weren't asked for it, the bond angle is going to be 109.5 or there or thereabouts. The shape I've given there as the tetrahedral structure. The double bond is shown with the 2 lines there. The chlorine is in the same plane, as the phosphorus, that's the solid line, the wedge coming out of the plane, and the dotted line, the bond going into the plane, and that's a tetrahedral structure. So next we're going to give the shape for the Cl4 minus molecule, or the Cl4 minus molecular ion. The central atom is chlorine, surrounded by 4 atoms of fluorine. The outer electrons of chlorine are given dots. So far we've got 5 dots, 6 dots, 7 dots. Now I'm only going to put chlorine to fluorine single bonds to begin with, see if that works. And you can see that some of those electrons are going to be involved in the bond to fluorine. So 4 chlorine to fluorine single bonds, so there are 4 dots between the chlorine and fluorine atoms, and there are 3 electrons which are not involved with bonding. There's the 4 single bonds, so I'm showing electrons from fluorine as a cross. There's the remainder of the outermost electrons in each fluorine atom, so fluorine again is in group 7, so 7 crosses in total for each fluorine atom, and each fluorine atom has got its full octet of electrons. Chlorine can also expand its octet. It is a Cl4 minus ion, so there must be an extra electron from somewhere else, which I've shown there as a cross. It is an ion, so we can show that it's an ion by putting square brackets around it, and it's got a minus charge. Now we weren't required to do the dot and cross diagram for this question, but it helps us to understand how many lone pairs and how many bond pairs of electrons are around that central chlorine atom. 4 bond pairs of electrons, 2 lone pairs of electrons. We can show the lone pairs in those lobes, and we can show the bonds coming out of the plane of the screen with a wedge and into the plane of the screen with a dotted line. You just simply have to know that that's going to give you a square planar configuration, and the bond angle will be 90 degrees.